Hello and warm welcome to today's episode. Today I want to talk about how to get data to Microsoft Fabric in the best way depending on your scenario. I know from a lot of conversations that this can be quite challenging because there are just like basically 1 trillion ways how to do it, and it's kind of hard to find the best way if you have a specific data source to figure out what is kind of the best approach to get the data in. There are just too many options, right? There are data pipelines, data flows, shortcuts, mirroring, and whatsoever. Yeah. So today I want to show you actually an easy to follow decision tree to navigate you to the most promising way to onboard your data to Microsoft Fabric, which basically looks like this. But before we come to the decision tree, I actually want to give you a short overview which kind of mechanisms there actually are to bring data to Microsoft Fabric to have like some kind of understanding how they work and what are their kind of key advantages and disadvantages. I mainly distinguish between like two categories. One is like which I call pull mechanisms in that sense of Microsoft Fabric is in the lead here. It's some kind of functionality which comes out of the box with Microsoft Fabric to kind of pull data from specific sources. Um, and the other category I would call like push mechanisms. It would be all about like using some kind of tool or script or whatsoever to land the data to those specific endpoints and landing zones interfaces Microsoft Fabric is providing to bring your data to the platform. So let's have a look first on this overview and on all these mechanisms, and later on I will go into more details about the decision tree. So here we are with the full overview of all the pull mechanisms. That means like all the mechanisms you have right out of the box with Microsoft Fabric, capabilities you can use without using additional tools, additional scripting outside of Microsoft Fabric. You can just go to the portal or use the APIs, create those tools and start working with it. So first of all, we have like the so-called data pipelines. They are, if you're familiar with the Azure Data Factory, it's like a mechanism to use like out-of-the-box connectors to connect to a large variety of data sources, build this connection, extract the data from there, using so-called copy activities to land the data in Microsoft's Fabric's OneLake. Um, in the event house or somewhere else. It's also useful for orchestrating a data pipeline, a ETL process end to end. And of course, it has also some capabilities to connect to private data sources using data gateway. So you can actually extend your reach also to private data sources by using those data gateways which live in the virtual network of your data source, so to navigate around the firewalls and network security. Some kind of drawbacks, it's like by design a batch process. You can't do much transformations. You have to schedule this batch process, and obviously you're also kind of limited to those connectors which pipelines bring. It's kind of beyond the scope of the out-of-the-box connectors. It's kind of tricky how to get there. So for like these large scale ingestions, if a connector is there, that can be pretty powerful. The second option I want to talk about is the data flows Gen 2. They are very similar in the sense of they use like out of the box connectors. They are currently even more connectors than for data pipelines. They basically use all those connectors which you're used to from Power Query, and also like how you build a data flow Gen 2, define the logic is based on this Power BI, Power Query experience. It allows you to do like transformations on the fly, like aggregations, filtering out specific columns or rows, and it also uses data gateways to reach those private data sources behind firewalls and private networks. As of today, I have to say they are not super performant. I know there's a lot of work going on there to make this more efficient, but from the conversations I had, I get a lot of feedback that like especially for larger scale, or if you want to run this very often, that the performance is not so convincing. And it's also by design a batch process. In that sense, you have to define when this data flow should run, when the data is going to be updated using those data flows. Um, it's pretty convenient, yeah, for using, having like this possibility to use a low code, no code tool for data transformation and ingestion, and for small and medium scale, it can be also quite efficient there. The next mechanism I want to talk about is end-to-end mirroring. It comes with out-of-the-box near real-time replication and is also very easy to set up. That means what is end-to-end mirroring? It's basically you connect to a specific data source. It's, to be honest, very limited though, what kind of data sources are supported there. But if you set up this connection, it will actually automatically run in the background all the time, and with a delay of let's say like 1 to 5 minutes, the data from the original source will be replicated to your location in Microsoft Fabric. So you get a specific item there, so-called mirror database, which has a SQL endpoint, analytics endpoint, and the tables can be shortcutted then within Fabric. So it's a very convenient process to have like this replication of your data source and making this data available without setting up some kind of complex ETL process. Obviously, with the replications, there are no transformations happening. This end-to-end mirroring is very limited, which kind of data sources are supported there at the moment. And at the moment, it's also there's no support for private data sources. Yeah, so this can be quite some limitation where you can use it. But in general, from my perspective, um, this this way is very efficient, yeah, to get the data there. So my recommendation there is basically to use it whenever possible and applicable, to have a look at mirroring here. Another one which is very interesting and basically is also new with Microsoft Fabric are the so-called one-leg shortcuts. They don't even have to do a replication of the data, so you don't have just this kind of overhead of creating a copy of the data. And this also means it's always using up-to-date data. How does this work? Basically, one-leg shortcuts create a reference, a symbolic link to the original source of the data. And whenever you have a workload in Fabric, making use of the data, it will actually fetch the data directly from the source. And this, avoids of having the data replicated, and also obviously you always get the data at that point of time. From the extraction, so it will be always up to date in that sense of it will be the same kind of version which you have in the original data source. I mean, it's only working for a specific data source, namely data lake and cloud storage. Yeah, because like the Fabric One Lake works in the way of having this a focus on being using a data lake as the data foundation. So only other data lake and cloud storage is like Azure Data Lake Storage Gen 2 or AWS S3, Google Cloud Storage, or even like other solutions which can be even deployed like on-premise, which have like a S3 compatible API. They can be connected here via one-leg shortcuts. The next mechanism I want to talk about is like the Spark functionalities you have in Microsoft Fabric. So you can some main advantages here is you have the power of the Spark cluster for large scale ingestions and transformations. You have the full flexibility in Fabric to install additional libraries using SDKs. To kind of extend which kind of connectors you can use there. So this is from the range of connectors the one of the most powerful mechanisms. Um, uh, Limitation is, I mean, you use like a compute which is kind of only working or running in your Microsoft Fabric environment. So you kind of are limited when you have to access private data sources. So this can be a little bit tough. And I mean, you're not using like Fabric managed connectors, which are basically coming with the platform itself, where there's an SLA behind. You're using like libraries, maybe open source libraries, and it's your kind of responsibility if these connectors work or not. But when applicable, it's quite convenient for like if you prefer a code first approach and have like either a very large scale batches, you can use it for that pretty efficiently, but also like for streaming, and obviously you can do the transformation with your Python, PySpark code on the fly. Um, and the last one here is more like specifically for streaming data. There's the so-called event streams for managed stream ingestion. They come with out-of-the-box connectors to the most popular streaming data sources. And for streaming scenarios, that's one of the most efficient ways to get data into the system, but not for like other scenarios, obviously. Let's come to the so-called push mechanisms, how I would like to call it. It's all about mechanisms. How do I get data to Fabric with other tools, with my own scripts, with my existing ETL tool? What are kind of the interfaces I can use to land that data here? Um, First of all, you can always kind of write to one lake. So the Microsoft Fabric One Lake, it supports the same API as the Azure Data Lake Gen 2. So basically like the Blob API or the ABFSSS API. So basically having URLs like this, starting with these kind of prefixes here. So if this looks familiar to you, or if you're used to using these APIs, then you're good. You can actually also write directly then to one lake. So you can even use tools like Azure Storage Explorer, or like if you have some kind of data onboarding and transformation jobs in Azure Databricks or Azure Data Factory. Um, you can also use those connectors there and write to those places in your Microsoft Fabric One Lake. Um, when to use, I mean, this is kind of the least Fabric managed way, but also kind of the most flexible one. Yeah, I mean, any kind of tool which allows you to do so can be used to kind of land the data here. Another way is open mirroring. So I touched upon end-to-end mirroring, how I would call it, is in contrast to open mirroring. So Microsoft Fabric offers this framework to do mirroring for any kind of data source. Um, but only then the second part of the replication. So the first part that would be your responsibility. So that means the first part is about making sure that you provide the incremental changes in your data source and land these changes in a specific format in a so-called landing zone of a mirror database item. What does this mean? So when you start doing open mirroring, you create a so-called mirror database item in Fabric. It comes with a specific landing zone, and it's your kind of responsibility to land the increments of the data, the deltas in this landing zone. And the open mirroring will make sure to use those increments and merge them together and actually populate this mirror database item, which you then can use to shortcut specific tables internally within the Fabric platform, or even use like the SQL Analytics endpoint or a semantic model directly on top of it. There's like a bunch of other videos. I will probably also do a video about open mirroring specifically, but this is actually also a very, very powerful mechanism from my perspective. Another option here is, I would say, like pretty hacky in that sense. I mean, you have like the SQL endpoints of basically all kind of data stores in Microsoft Fabric, but specifically the ones for like SQL databases and warehouses. They are not only read endpoints, but also write endpoints. So you can actually run some insert statements there, or eventually also use like ETL tools which connect to a MS SQL endpoint and let those tools connect to these endpoints of these components and actually, in the background, create those insert statements and land data this way. To be honest, that would be kind of pretty hacky, especially for warehouses. I mean, for SQL databases, that's pretty normal, but for and in that case, it would be kind of specific for that if you want to land data specifically in the SQL data warehouse. But for warehouses, I would not really recommend to do it like this. But this is here also for like to give you like the holistic view what is possible. The same then also for streaming, we have like the event house ingest. That means like those Custo databases also offer APIs to ingest data directly via these APIs. There are also some SDKs and libraries to land data in a Custo database directly, and this can be used. So this would be applicable like if you don't want to event streams, or if they are not applicable for your real-time intelligence use cases, you could also connect via those APIs. And the last one is here the event stream endpoint. So basically, if you create an event stream, you can actually say, I'm not using an existing connection. I'm not directly connecting to a streaming data source, but I will be like the endpoint where you might have some IoT gateways which want to connect to this endpoint, so they can directly send their data to this endpoint, and this endpoint is over Azure Event Hub nature. Yeah, so you can set up an event stream, you get like an Event Hub endpoint, and you can send events directly to this endpoint using the same SDKs you would use for Azure Event Hub. And basically land data that way. So that can be a very generic approach for your real-time intelligent use cases to bring your data for this for these scenarios, to bring them into the platform. So these were kind of the most commonly used mechanisms how to bring data to Fabric, or the mechanisms you can use directly in Fabric to bring data into the platform. Before we jump to the history, just one comment. So I told you a lot of mechanisms. So what are my personal favorites? So for pull mechanisms, I would really look closer on basically these two mechanisms here. So kind of looking into if the data source you want to onboard, if it's like one of the supported data sources for this end-to-end mirroring, and like if you don't face with those limitations, that could be a very very, very efficient way how to onboard the data here, and especially also the one-leg shortcuts. If you have data lake or cloud storage, you want to onboard the one-leg shortcuts would be, from my personal perspective, a very efficient way to bring this data in. On the other side, for push mechanisms, um, I also see a lot of potential with the so-called open mirroring. For the same reasons why I think mirroring is pretty powerful, open mirroring kind of extends that to, yeah, kind of basically any kind of data source. I mean, it requires to land the increments of the data into the landing zone by yourself. But I see a lot of a great future here for also partner solutions. We also already see this for SAP data, for Oracle, for MongoDB data, that we have that we see those partner solutions which offer this open mirroring functionality. So it's not even up to you to kind of design that from scratch, but you can just buy this partner solution for your specific data source. So that will in the end be a very efficient way also to onboard a large variety of data sources in a very efficient way. Yeah, you have this near real-time replication which runs automatically in the background, where you don't have to have a closer look or kind of schedule this dispatch process, these pipelines and stuff. With that being said, let's move also to the decision tree. So we know all the mechanisms now, but maybe you're now even more confused than before. Even learned about some new mechanisms you weren't really aware of. So I created like this decision guide to kind of help you in navigating that, basically coming from the top and thinking, okay, I want to onboard a new data source. Where should I look first? Yeah. So the whole idea of the decision guide is not being like 100% correct of the times, but basically the idea is, where should I look first? What would be like, from the raw requirement, what would be like a best first option to look at? I actually included this also in the decision tree, that you always see like, but if this optimal solution, or this probably optimal solution, is not working for me, what would be the fallback? Yeah, what would be kind of the next option I would have a look at? Just to give you like this kind of idea of, okay, these are kind of the mechanisms I should have a look at first. Eventually, it will always end up in some kind of mechanism you can always fall back to. So there's basically no scenario which or a specific data source which would be impossible to onboard. But there are ways which are more efficient than others, and that's what this decision guide wants to help you with. So here we are in the data onboarding / integration guide. It works pretty simple. Yeah, you start from the top with this triangle. You have questions in these blue ellipses, and eventually you end up in these green, or eventually also a red box with like different tools you can use for onboarding your data. So basically, which kind of answers you give on these questions in the blue ellipses, you might end up in a different, I would say, like default solution you should look into first. And I mean, every solution has a fallback. I mean, in reality, maybe what you end up here in the first place might only be suitable in, let's say, 70 or 80% of the cases. But I mean, the whole thing of this guide is basically to give you a good entry point, to give you like a good starting point to find the solutions which, yeah, from the raw requirements might seem like a good fit, but in the end, we know it always depends on your specific requirements, like on the details, what is the best solution in the end. I also have some symbols here when it comes to the solutions. Star means it's an out-of-the-box managed Fabric component. So you just go to the Fabric portal, you can set it up. There's no additional tools required, also no coding required using some libraries or something.
And the flames on the other side, they mean you need like additional tools. You need to use other libraries or so, write your own code to make the connection. That's what the symbols are for. So let's start at the top. So basically, the first question you want to answer is: do you want to land/onboard the data first, or do you already want to do some transformations on the fly? So basically, deciding between ELT and ETL. Typically in these cloud data platforms, especially also for Fabric, you might want to land the data first, have like a copy of the data or a reference to the data, have the data as it is in your original data source, and bring this to Fabric, and then do the transformations within Fabric using like the scalable compute, the flexible choices you have how to do the data transformations. But the choice is up to you. Yeah, so there are both options available. Let's look here first. If you want to land the data first and do the transformations later, the next question you want to answer is it like cloud? Is the data you want to onboard? Is it in cloud storage or object storage? That means, is it stored in something like an Azure Data Lake storage, AWS S3 storage, Google Cloud storage, or other solutions which even run on premises like MinIO or something like this, which have like S3 compatible APIs. They also fall under this category. If the answer is yes, then we are already looking in the direction of shortcuts. But what you might want to ask first is this data managed by Azure Databricks Unity Catalog? So are you working with Azure Databricks using the Unity Catalog, and you have all kinds of tables there? And this is managed by Unity Catalog. There's actually a feature then which you might want to look in first. That's called Databricks Unity Catalog mirroring. I made a whole video about this, how to set this up, but it basically does the synchronization of this Databricks Unity catalog, and it's in the background, it's creating all these OneLake shortcuts for you automatically. The fallback for this one, and also if you say, okay, I have cloud storage, but has nothing to do with Azure Databricks Unity catalog, you want to look at OneLake shortcuts. So that's especially true, for these data lake and cloud storage on these different hyperscalers. There's even like OneLake shortcuts for Dataverse data when you have the link to Fabric enabled. So this is what you want to have a look at for these cases. If you don't have cloud storage or these others options don't really work for you, then the next question you want to answer is the data semi-structured or structured in comparison to unstructured data like images and documents and so on? If the data is structured or semi-structured, that means like CSV, Parquet, JSON files, then you might want to look into kind of mirroring solutions. The question here is there an out-of-the-box mirroring for the data source possible? So is there something like, do we support like out-of-the-box mirroring? That means like for Snowflake, for Azure SQL, for Cosmos, you can actually directly build this connection in Fabric, have this end-to-end scenario cover directly managed from Fabric. In other cases, for other data sources, you might want to have a look in or actually answer that question. Are you open to use like also third-party solutions, community solutions, open source, or even build your own customized mirroring solution? If the answer is yes, if you're open to that, if you want to look into that, then I would really recommend to see like if open mirroring would be an option for you. As I explained before, that basically means you have to bring the change data, the increments, and land this into a so-called landing zone of a mirror database. And Fabric is doing the rest of merging these changes together into your tables in this mirror database. And there are even like partner solutions already which do like the first part of the mirroring, bringing this change data, these increments to this landing zone. So for SAP, for Oracle, for MongoDB. There are already partner solutions there. I also provide the link to that in the description of this video. If you're not really open to that, or if this is just not working for you, if you then the next question is basically, do you prefer to onboard this data with something low no code, some tooling where you can drag and drop stuff, where you can just select a specific transformation steps and so on, or define like this pipeline by yourself, or do you want to really code this and work in this code style as a developer? That's also actually the option where you would end up directly if you say you want to do transformations on the fly. All this stuff on the left side, like the shortcuts and the mirroring, it's always a one-to-one replication or reference to the data as it is. Anyway, if you prefer low and no code, you want to look into data pipelines and data flows. So my suggestion would be like, if there's a Fabric data pipeline connector already existing for this data source, I would actually also prefer to use the copy activities, just because it's kind of scales better. You can directly build this end-to-end pipeline and orchestrate it via that data pipeline. So you might want to look into data pipelines or copy jobs. If this doesn't work for you, you want to do more transformations, for example, or the connector is not there, you might want to answer the question, is it structured data, and is the data volume size small and medium, like a couple of gigabytes and so on? In that case, Dataflow Gen 2 could be a really good option for you. It comes with a lot of connectors, so you might want to look into that. Maybe before we go to the last, where everything falls back to, if at this point you said like, I want to do transformations on the fly, or mirroring or one legs don't work for me, and I prefer a code first approach. I want to work, have some scripts or notebooks to do the data onboarding. Then one question which is left here is this data source reachable via public endpoints or a Fabric managed private endpoint? That means like, is it some kind of data source which is reachable via the internet with a public endpoint, or is it some kind of Azure resource where you can build a Fabric managed endpoint to it? If the answer is yes, then you can run this code directly in Fabric Spark, so using a notebook or a Spark job definition. So you could create two like private Azure data sources like ADLS Gen 2 or Azure SQL and data sources like that. Or if you grabbing data from public APIs, that could be also a very good option if you prefer this code first approach. Where everything falls back to, and if you answer those questions with no, the best way to kind of push the data to Fabric in a very generic way is to write to OneLake. So basically you create a lakehouse, and then you have like the path of the Azure Data Lake storage account, basically, and you can use this API to write to OneLake directly. And there you can use like non-Fabric tools, like even other Azure tools are considered here, like Azure Data Factory, Azure Databricks, but even other ETL tools like Fivetran from Stream or whatsoever. Use these kind of tools to land the data directly in OneLake. As I mentioned with the symbols, so on the left side, you have a lot of options here with a star, which basically means they directly come with Microsoft Fabric. You don't have to do any kind of use additional tooling or write some code. Then we have like these kind of hybrid solutions, open mirroring. There you have the one part, the second part basically of this mirroring process is managed. The first part is you have to have some partner solution, open source community solution, or your own individual build solution to kind of land the data. And I also considered here for Fabric Spark, you have to write your code, you have to use some kind of libraries to connect to those endpoints, to these data sources. So that's why this is also kind of hybrid. And this write to one leg, it's basically not using kind of a real Fabric functionality. So it would be completely up to you how to land this data to one leg. So this is it. So I wanted to show you like which kind of pull and pull mechanisms you have with Microsoft Fabric to onboard your data. Also giving like this decision guide to helping you navigate, okay, which kind of option should I look first if I have a specific data source. I hope this helps you, and I may provide all the material or the links to those different mechanisms in the description of this video. If this video helped you and you want to see more content like this, please like the video, subscribe to the channel, and I hope to see you another time. Thank you very much.